All right, guys. So moving on to part B. Can we quiet down? We have summation of k equal to 1 going to infinity of k factorial of 1 times 3 times 5 dot 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 2k minus 1. Okay? Since we have factorial in this, it's a big giveaway that we will be using the root test, the ratio test. So the ratio test is we can make p equal to the limit as n approaches infinity of a sub n plus 1 divided by a sub n. Okay? Can you guys see this lower part? Or should I just go to the top? I'll go to the top. Yeah.
Is it absolute value?
Yeah. So then p is equal to a sub n plus 1. Wherever we have an n, we add a 1. So we have n plus 1 factorial divided by 1 times 3 times 5 dot dot dot. And we can say, since we have 2k minus 1, we can do 2 times n plus 1 minus 1. Okay? And this becomes 2n plus 1. So then the term before that would be 2n minus 1. Did that make sense? Because we're going, since it's n plus 1, we're going 1 digit ahead of n. Okay? So then we had 2k minus 1, and then where there was a k, we plugged in n plus 1. So we have 2n plus 1 here. Did that make sense? You don't just automatically add 1 here and go to like 2n. Yeah.
Do we have to put those on this?
Put what?
Like the last part, like the 2n minus 1, because it just ended up in a
No, you should put that one there. Because you have to use it to cancel. Oh, limit. So let me say that again. We have 2k minus 1, right? That's the term when it ends with n. If we want to go with n plus 1, we replace k with n plus 1, and then we have 2n plus 1. Okay? And normally, instead of writing another division, I multiply by the reverse of a sub n. So we will have on this side 1 times 3 times 5 dot 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 of 2n minus 1 divided by n factorial. Does that make sense? You can either just write a whole division sign and rewrite a sub n, but I flip it and multiply it. It makes it easier for me to see where to cross out. Okay? So what's the first thing we can easily cross out? Is this. Good. Next, we can see that this is n plus 1 factorial. That's equal to n factorial times n plus 1. Do you guys all see why that is? N plus 1 factorial is equal to n factorial times n plus 1. Do you guys all understand that? Yeah? Okay. So then the n factorials cancel out. we are left with the limit as n approaches infinity of n plus 1 divided by 2n plus 1. How do we simplify that? Multiply by 1 over n divided by 1 over n. That's equal to the limit as n approaches infinity of 1 plus 1 over n divided by 2 plus 1 over n. That's equal to 1/2. So what does that mean? 1/2 is less than 1, and in a p-series, if it's less than 1, the series converges by ratio test.
How do you know it was a piece?
Did I say that?
Yep.
Yeah, okay.
Oh, sorry. It's a ratio test, not p-series. So it equals 1/2, which is less than 1, and in a ratio test, if it's less than 1, it converges. Okay? What if in a ratio test it equals 1?
Failed.
It fails. Then you use a different test to find if it works. Okay? So any questions on this problem? No? Pretty simple? You guys are going to get 100 on this?
That was so great. Oh, Daniel, he has a question? He has a question.
Yeah.
Yes, I do that. 2n minus 1 is 2n plus 1. Can you explain that one more time?
Yeah. So the original problem had 2k minus 1 in it, right?
Yes.
That's the place value for n. We need to go n plus 1. So if we replace k with n plus 1, so it's 2 times the quantity n plus 1 minus 1.
Mhm.
And then you simplify that to get 2n plus 1. Okay?
I've got that part. I'm talking about the 2n minus 1 right.
This is still n. So this is 1 times everything times n plus 1. So this is still the quantity up to n, and then the next term will be 2n plus 1. And then if you were to find a term after that, you would replace, instead of n plus 1, you'd put n plus 2 here, and then solve that out. So any other questions on this? That was good. Can I erase this? Part C says to use the root test, and on the exam, they probably will not tell you to use what. I don't remember them telling me what to use, but on this exam, as I said before, they do say to use the root test. So just be careful, and if they don't say anything, you can do whichever test. So this is the summation of k equals 1 going to infinity of 3k minus 1 divided by 3 plus 2k to the power of 2k. And since it's to a power, it sort of tells us we need to use the root test whether they tell us to or not. So p is equal to limit as n approaches infinity of a sub n, so 1 over n power. That's equal to the limit as n approaches infinity of the quantity 3n minus 1 divided by 3 plus 2n, the power of 2n, n quantity 1 over n. Okay? Now, say you had 2k squared. What would your 1 over n be?
So you have what?
2k squared. It would still be 1 over n. You will not do 1 over n squared. Okay? You would still do 1 over n, and then you'd have an exponent power here. Okay? And there's an example in Dino where they did in class. Then you have to do y equal to that value. You do natural log and all of that stuff to simplify that. Yeah?
57.
Yeah, if you still have an n. In this one, since they're the same degree, you can cancel them out, so we don't have any n's as an exponent. Okay. So this is equal to limit as n approaches infinity, and we those cancel out. So if those cancel out, not looking at the 2, what can we do inside to simplify it?
The 1 over n.
Multiply by 1 over n. So we have 3n minus 1 divided by 3 plus 2n times 1 over n, quantity squared, equal to the limit as n approaches infinity of 3 minus 1 over n divided by 3 over n plus 2, quantity squared. That now, since 1 over n, everything divided by an n goes to 0, we are left with 3/2 quantity squared. That's equal to 9/4. So what happens? That's greater than 1. So what happens to the series? Yep, the series diverges by root test. The ratio and the root test follow the same rules, which is nice. So any questions on this? It's just putting a sub n times 1 over n and then simplifying the limit. You guys have it copied down? Can I raise it? Or should I go to the lower roll? Okay. We will erase it. Final questions on this problem. So did the first page seem easy to you guys?
This is an actual exam.
I know, it'd be, if this was an actual exam, it'd be so awesome.
Okay.
Okay. And some people did have this. So, you know,
Someone had that?
be glad that this happened when you.
That also means it's not gonna be always.
Okay, so we need to find the interval of convergence, okay? There's 2 tests we can do. We can either do the ratio test or the root test, okay? And you just have to look at the problem. So we have the summation of k equal to 1 of infinity of x minus 4 to the k divided by k times 2 to the k. So I would recommend that we use which test here? The ratio test. Why not the root test?
Because they don't do that.
Yeah. The only reason I can think of is you can't put everything to the k power because we have a k here that doesn't have a power. Otherwise, if this k was to a power, you could just have a parentheses and put k as a power, right?
Yeah.
But this k doesn't have it, so we have to use the ratio test. Okay. A sub n plus 1 divided by a sub n. That's equal to the limit as n approaches infinity. Quantity. The first one, we have to do n plus 1, so we have x minus 4 to n plus 1 power divided by n plus 1 times 2 to the n plus 1 power. And then, as I said before, I normally just multiply the reciprocal, so then times n times 2 to the n power divided by x plus 4, x minus 4 to the n power. Okay. What are some things that we can cancel out here? This x minus 4 can be broken into x minus 4 to the n times x minus 4. Because when you have two things of the same base multiplying, the exponents can add up. So we have n plus 1. So we can actually cross out x minus 4 from there. This 2 to the n plus 1 is equal to 2 to the n times the 2. So then the 2 to the n's can cancel out. And we are left with, as n approaches infinity, of the quantity x minus 4 divided by 2 times n plus 1. What can we do to get rid of the n's? We have an n here as well. Multiply by 1 over n, 1 over n. So this is equal to the limit. Oh, and one thing I forgot to mention, we do cross out an x minus 4 in the denominator, okay? So then we have a restriction that x cannot equal 4. And then since we are finding out the intervals which the series is converging, we need to look at it quickly. If we were to plug in a 4 here, the series would equal a 0. So this is very important that you guys say this. Note, series converges to summation of k equal to 1 going to infinity of 0 to the k power divided by k times 2k equal to 0 plus 0 dot 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 equal to 0 for x equal to 4. Okay. Since we did find a restriction, we need to find whether it converges or diverges at that position. And since it's in the numerator, if we plug in a 4, the series equals to 0. So we say it converges at that point. Then you have to look at it, and if say you get like infinity or something, and you say it diverges at that position. But you have to then note it in the final interval that you find. Say it diverges and 4 is in the middle of your interval. Then you need to put separate it and then put parentheses at 4. If you guys
here that summation there with the 4 to show that it goes to 0.
What?
You need to show like that whole summation thing.
Yeah.
Oh,
Yeah, you need to show all of this for points.
okay.
Any questions on how we got that? Since we simplified it, it was our restriction. And going back to this, we are multiplying by 1 over n. So we have a limit as n approaches infinity of 1 divided by 1 plus 1 over n times x minus 4 divided by 2. That's equal to the 1 over n goes to 0 as we approach infinity. We are equal to the f value of x minus 4 divided by 2. Okay. Any questions on that?
Why is absolute value?
Because that's the ratio test. It's the absolute value of a sub n over a sub n. So are you guys good with this part? So normally with the ratio test we'd have a number, but since this is only true for certain values of x, we still have an x in the absolute value. So we are looking for where the series converges, okay? And in the ratio test, what is the ruling if we wanted to converge, it has to be less than 1, right? So we have to set P, which is equal to this, less than 1. Okay? You guys all understand that?
Is that P or rho?
I don't know.
It's rho.
Is it wrong?
Yeah, I mean, but you draw it the same way.
Yeah. But like sometimes they draw a row like that, sometimes like that. But
Draw it with fancy tail.
well, I've been calling it P this whole time. You can call it rho if you want. So any other questions on why we have to do it less than 1?
When she does examples in class, she writes out like all the stuff that like
Yeah, we're still going to do that. Yeah.
Yay.
But I just wanted to make like a huge point here that because we can set it less than 1, that's why we know the x values that we'll find will be the converge interval. Okay? If you were to do a divergence or something, it'd be greater than 1. Therefore, the absolute value of x minus 4 less than 2. And then we simplify that, we have -2 less than x minus 4 less than +2. Therefore, trying to find x, we have 2 less than x less than 6, which is equal to the interval of 2, 6. So now everything in this between 2 and 6 converges, okay? And we know at 4 we converged as well. So then that interval is fine and it includes 4. But what?
We don't have to rewrite that.
No. The one thing now that we need to find out is that in the ratio test, when it equals 1, the test fails. Okay? It doesn't mean it diverges or converges. We don't know. So we have to use some other test at the endpoints where it equals, where it's equal to a 1 to find whether it converges or diverges. Okay? So we don't know whether it's going to converge at 2 or diverge at 2, and same for 6. Do you guys have this copy now? So then we test the endpoints. So let's look at 2. We have the summation of k equal to a 1 going to infinity of x minus 4 to the k power divided by k times 2k. So if we were to plug in a 2 for the x value here, we get a -2 to the k power divided by k times 2k. You guys all see that? Yeah. So then this is equal to, by simplifying, we had, this is the same thing as a -1 times a 220 to the k. Okay? The 2 k's can cancel out, but we are still left with k equal to a 1 going to infinity of -1 to the k power divided by a k. Did that make sense? This is a -1. We can say to the k power times 2 to the k power. The 2 to the k powers cancel out. We're left now with this. What do you guys call this? Alternating harmonic series. And what happens to them? So which converges because alternating harmonic. Any questions? So now we know that at x equals 2, it converges. We still need to find out at the next endpoint, which is x equals 6. Okay? So at x equals 6, we have the summation of k equals 1 going to infinity. We plug in a 6 instead of a 2 here now. So we have 6 minus 4, which is 2 to the k power divided by k times 2 to the k. The 2 to the k's cancel out. So we have the series 1 over k, which is what? Normal harmonic series, which diverges, right? Diverges because it's a harmonic. Okay, so now we know the endpoints as well. So we can make a final statement overall for the entire problem. Given series summation of k equal to 1 going to infinity of x minus 4 divided by k times 2 to the k converges on I including 2, comma 6, parentheses because not including 6 on the interval. Or you can say 2 less than or equal to x less than 6. Yeah.
Let's run another statement in our class that said like and diverges elsewhere. Do we do that? Is that
No, I don't think that's necessary.
okay?
Because when you show I with that interval
Yeah.
on the answer test, they don't show it. Did this problem make sense? I hope now you can essentially do the whole process on the actual exam. Yeah.
How do you know when you should do the
The endpoints? Because when the ratio test or the root test, whichever one, when it equals 1, we don't know. Okay? That means we need to use some other test to find out. It doesn't mean that it diverges and we just ignore it. It just means we don't know. Okay? So when we found out by setting it less than 1, we found out where it definitely converged because it's less than 1. We just don't know for 2 and 6. So then here we use the harmonic series and alternating harmonic series to find out what happens at those points.
How did you know to set it less than 1? Like I understand why it's less than 1, but how did you know to set it to?
Because in a in a ratio test, when it's less than 1, we know it has to converge. So we know we needed to set it less than 1 for this whole entire value to converge. Are you guys good? And I'll do the next one on this. So this one, they tell you to test for absolute or conditional convergence or divergence. Okay. So just a thing, since for part A, I don't know if I showed this on the practice exam, but they provide a very small space. Okay. So what does that mean?
Doesn't take that much.
It doesn't take that long, which means that it will probably absolutely converge. Okay? Since on the exam they don't give you that much space to write, it's sort of, probably will absolutely converge. Not all the time, but
She does it on purpose.
because sometimes they do that to save space.
You say that the inversion is true, and that would give us a lot of space.
They could do that. Sometimes they just have a lot of things they want to put on the test, so nothing has enough space. Sometimes you just have to write really tiny. But in this old exam, they give very small amount of space. So knowing that, we have summation of k equal to 1 going to infinity of -1 to k plus 1 divided by k to 3 halves. So the first thing that we always do is test for absolute convergence, okay? So one test for absolute convergence. You do that by taking the absolute value of a sub k, which just means getting rid of the alternating series part. So this becomes summation of k equal to 1 going to infinity of 1 over k to the 3 halves. Because when you do an absolute value, you can't go below 0. So then the -1 part goes away. So we have 1 over k to the 3 halves. Now, since we have 3 halves, right? 3 halves is greater than what? 1? So what happens? It converges because of the P series.
I'm sorry.
Does that make sense?
Is it a pieces?
Yeah.
What if we have like a -2 to the k plus 1, we just make it a 2 over k to the
Yeah.
halves, whatever.
Because it's absolute value. So then we have to say series is absolutely converging. Any other questions on this? Yeah.
So when we have harmonic or alternating harmonic, we don't have to write, that's not p-text, right?
It's a short form of a P-series test, but you can just say harmonic or alternating.
Well, they give us just any string of p-tests.
Yeah, that's just too easy.
But no.
This was on an actual test, so. But yeah, you guys, or I never had anything as simple as this. Okay. So when you do the first part and it absolutely converges, what do you do next? What? When you do the first part and it absolutely converges, what do you do next? Well, if it absolutely converges, you're done. Okay. If it diverges, it could still conditionally converge. So for part B, we have the summation of k equal to 1 going to infinity of -1 to the k plus 1 divided by k to the 1/2. So this time we have k to the 1/2, and we know that's less than 1, but we still need to show our work test for absolute convergence. Summation of k equal to 1 going to infinity of the absolute value of a sub k equal to the k equals 1 going to infinity 1 over k to the 1/2, and we know that diverges because P series, and you do need to state P is equal to 1/2, which is less than 1.
I think both of them are 1.
Yeah. So one of them was greater than 1, one of them was less than 1. So now we know it doesn't absolutely converge, so we need to do the test for alternating series test. So the first part is saying u sub n is equal to the absolute value of a sub n, which is -1 k plus 1 divided by, n plus 1 divided by the square root of an n. Now that's equal to 1 over square root of an n, and that's greater than 0 for n greater than or equal to 1. Because when you do an absolute value, it should be greater than 0. The second part is to show that it's decreasing. And there's always two ways to do that. You can say u sub n is equal to 1 over square root of n, which is greater than 1 over the square root of n plus 1, which is equal to u sub n plus 1. Or you can say that f of x is equal to 1 over square root of x. Therefore, f of x, f prime of f of x is equal to negative 1/2 x with 3 halves in the denominator, which is less than 0. Therefore, decreasing function. I normally just do the first part.
Does it normally work out with the first part where if the use of n is always greater, or will they try to trick us and make it where it's less than?
I think it will always work out.
It will always work. Okay.
In my experience, it has always worked out.
Okay.
Unless they've done some problem in class where it hasn't. But it is doing the actual value. And the last part is the limit as n approaches infinity of u sub n equal to the limit as n approaches infinity of 1 over square root of n. And we know that equals 0 and it needs to equal 0. Since all of the three things are true, we can say alternating series converges by alternating series test. Any questions on that? And sometimes it may not pass, so don't just assume that it will pass.
If it doesn't, would that be at the last step, probably?
Yeah.
Did you say converges?
What?
Did you say converges?
Yeah. I'm going to write that here. So then we can put a 3 here. Change 3. Then the summation of a sub k absolute value diverges, and the summation of a sub k converges. The series a sub k equal to negative 1 k plus 1 divided by k to the 1/2 is conditionally convergent. Yeah.
How important are those statements are exactly like that? If we
I mean,
just
you-
forget a step or something like that, but we get to the series convergence condition or something.
It's probably worth like 1 point.
Okay.
But the things that you should have is the actual value of a sub k diverges, and without the actual value it converges. So then the summation of a sub k, CC, can be written short. Any questions on this? Did this make sense? Like, is your mind at peace with it or something? That will never
As
happen.
much as it can.
Can I move on?
I don't really understand the number two.
This one? So if u sub n is equal to the square root of n in the denominator, the next term, n plus 1, we know is lower than u sub n. Okay, so that means the next term after that has to be lower. So then the series is decreasing. And if you prefer this method, go for it. So any other questions? So this is essentially just remembering the steps. Shouldn't be hard. Sometimes you will use a p-series here. Sometimes you may even have to use a ratio test and stuff. Okay? Don't forget those in this problem. Can I erase it? And the last one is, most of it is just fill in the blank. Okay, so if f of x is equal to cosine of 2x, what is f of 0? 1. So then you just go down the list, you find f prime of x, f double prime, triple prime, fourth prime. So what would the f prime be? -2 sine of 2x. What would double prime be? -4 cosine of 2x. Triple prime? At 8 sine of 2x. And fourth prime. And then f prime here of 0, f double prime, triple prime, f to the fourth. So you'd have 0. If we plug in a 0 here, what would we get? What is f double prime of 0? -4. Then we have a 0 again, and then we have a 16 here. So don't just quickly go down and put 1, 0, 1. So that should be easy, right?
Yeah, we did it.
And this was 3 points. Part B is to write the first 5 terms. So then we would have f of 0 plus f prime of 0 times x divided by 1 factorial plus f double prime of 0 times x squared divided by 2 factorial plus f triple prime of 0 times x cubed divided by 3 factorial plus f to the fourth prime of 0 times x to the fourth divided by 4 factorial. Then we just fill in everything. We have 1 plus 0 minus 4x squared divided by 2 factorial plus 0 plus 16 x to the fourth divided by 4 factorial. So that shouldn't be hard, right? Yeah.
We actually write out formula for it.
On this, they don't ask that. On my exam, they did.
With the last word thing.
Yeah, if they want to.
We
Just-
did it, right?
Yeah. Just look over the quiz problem. I think that was a really good example of it.
Did they put the derivative point in there?
What do you mean?
Like, you know how they said, like, it's like find the
Oh,
series of like signs.
based on
Oh.
the fact that it's.
Yeah.
You will
Sorry.
learn how to do that a lot more unit 10.
Okay.
But if they mention in class, go over it. Yeah.
What was the universe formula? Like, stuff that.
Oh, e raised to the I theta equals cosine theta plus
I don't think you need
sine
to.
They've
theta.
never.
Yeah.
Yeah, they like.
Would they expect you to simplify it?
So for this, you could either leave it like this, or 1 minus 2x squared plus 2/3 x to the fourth.
Well, 'cause it says leave the zero terms.
It says find the first 5 terms, including the 0 terms. So these are the first 5 terms, including the 0, and then you can simplify it.
So if it didn't say including the zeros,
You would need to move further on.
So are they not gonna ask us to rewrite it as like a normal series, or they just might?
They might.
just-
Yeah.
Now, they give us a starting point with the K, or we have to start on K. I mean, if you have to start.
You would need to look at what you have, but for series, isn't it like when k equal to 0?
Yeah,
Yeah.
you can take the 0 or 1.
Yeah, so as long as the formula makes sense.
Okay.
Yeah. Like if you can start at 1 or 0 as long as the numbers work out. Unless they could tell you.
Yeah.
So that is the stuff Any questions on this problem? This was pretty simple. Yeah, study the exam quiz problem, and that should be good. And this was worth 5 points.
Any other advice?
About what?
I don't know, like, you got tips?
Don't have your phone